people trickling in, or they've turned around at this point, which is totally fine. Kind of a pleasure to talk to anybody who is interested in this stuff, but at the same time, you know, the more kind of information we can put out there, the better. So hopefully if anybody catches this recording, it will be helpful. But for everybody in the room, just because it's a smaller group tonight, dealing with the traffic and stuff like that, if anybody has any questions, we can kind of treat it more like a Socratic. I have prepared a talk that I can run in about a half an hour. It assumes that everybody knows what NFTs are and everybody's very familiar with the 10K PFP NFT project. If you're not, then let me know and I'll explain anything that comes up that might be confusing, or if maybe we have a conflict of what I said, that would be great to talk about that amongst ourselves as well. It's a small group, so I can probably move quite fast, but we also probably have an opportunity to discuss a little bit more than if it was a larger group, so that's fine too. I'm going to push through this. I do have a technical live coding session as well as that we were going to do tonight. If I was talking with a couple of the guys in the back who had computers. If everybody is kind of not so interested in the live coding session, then I can just go through it more as a talk. We can dig into some examples and see like how to use the Chainlink, VRF, and stuff like that. But if anybody wants to really dig in and download the repo and run the commands and stuff like that, we can do that too. So I'll just check in once we're done with this. I'm going to push through this really quick. I assume maybe some people will come in, but also it'll give us a chance to kind of set up for the Chainlink VRF portion of this with random minting. So I believe the flyer for tonight kind of might have alluded to this talk being about the options protocol that we work on. So SmartPiggies does an OTC options protocol on EVMs, but we're actually doing an NFT art campaign for fundraising, and that's what this talk is about. So if anybody wants to talk about, I know Nate was really interested in options, totally you can have that conversation too. If everybody wants to talk about that instead of fair minting NFTs, we can just talk about that, but you'll have to let me know. Let me know how to talk to us. This talk is going to be about how do we mint NFTs in a random way, and what are the benefits of doing that, and kind of what will that fix in some of the consequences of some of the traditional PFP NFT projects that we've seen so far. So I'll jump in. If anybody has any questions, raise your hand, or my name is Toby. Maybe I should start with that. I'm Toby. Just call out and we'll go ahead and address it. And I brought some prizes. The prizes are Rip Van Dutch Caramel and Vanilla waffles. So I thought these would be good. I was probably hungry when I bought them. So I'm going to ask questions, and if anybody has an answer, it could be right or wrong at this point. You probably can. But I do have a couple questions built into the talk. Who's technical here? Who can I pick on? One, two,
pick on
Chad. I'm going to be picking on Chad. Gentleman in the red, maybe Chase. Okay, I'm going to pick on everybody. And then it'll prompt a discussion, and maybe we can dig in a little bit more to some technical details. And then if anybody doesn't understand that, we can kind of like make that clear before we move on. So I'm going to push into this talk. Again, this talk assumes that you're familiar with the PFP 10K NFT project. If you're not, raise your hand or yell out, Toby, I don't understand. Jeff in the back. Yeah. Okay, well, I'll go over it, and then if I pass over anything and you're like, I didn't quite get that, I'm going to move quick, so just let me know, and then we'll talk about it. And I bet there are some people in here who also know about it too, so we can have a bit of a discussion. Okay, so the 10K PFP NFT project. This is kind of standardized right now. Everybody really, these became really popular over the kind of 2021 summer. There were some really popular projects that made a ton of money. So what is it? It's generally a 10,000 randomly generated and unique avatars. Generally, they're rendered in a profile picture format, so that's like 3/4. Body pose, they are using mix-ins layered one on top of another, and they are typically achieved with a generation engine like Hashlips, but there's a lot more by now, but Hashlips was the one that we used for our project. That's kind of the overview of what a 10K PFP NFT project is. I'm going then just check in. Yeah, kind of makes sense.
Yeah, so I actually know what that is. I just didn't know that was called a 10K PFP.
So kind of that's what we stamped it at. Now it's a 10K PFP NFT project. All right, everyone's learning something. So this is the Hashlips engine that we use. So typically, you're going to get a config file up here. It's going to have your total size of your collection, so it's 10,000. And then basically these layers are going to be listed here. And what's going to happen is you're going to build an image based off of all of these layers. So each of these layers are like a bucket. You're going to stick a whole bunch of stuff in any of those buckets. And then randomly inside of each of those buckets, the algorithm is going to choose a trait. And they all get kind of stacked up and layered on top of each other. So we've got the background, and for our particular case, we have this little tail, and then we get the body. And we have these rosy cheeks that get added. Those are the facial features there. Then we get eyes, hat, or headwear, mouth, and then eyewear, nose. Here's a loot box. And then at the very end here, we have like a fair ribbon. So it all kind of gets layered on top of each other to make that image. So that's what kind of how the engine will run. Yeah.
Do you have to have 10,000 of each item? Or?
So whatever you put in there is going to be what's made. Okay. So you don't necessarily have to have 10,000 items. That's your target. How many pictures do I want in this collection?
If I have 4,300 eye patches, that's fine.
So
take that into account.
So this is going to be how many of these get made. In any of these, you can put as many or as few or as many as you want. The difference is going to be how many random generation of traits can you produce. So the whole goal is that you can't, there's a goal that each one is unique. So all of the buckets, we call them buckets just so that we can kind of conceptualize this. So in bucket number one is let's call background bucket. There's only one. There's just one background because every image will get the same background. And the tail is the same. But the character, how many characters are there? Well, we had 12. Could be a 30, but if it's one, we might not be able to get uniquely generated images off of one character. So it's the same with eyes. I think we had 12 or 13 different eyes. And so those you can vary. But the 10,000 at the top is basically how many target characters do we want, and then depending on how many traits we have in each one of those buckets, we may or may not be able to achieve that much output based off of how many of each trait is in each bucket. Okay, so we all stack those up. So for instance, like these sunglasses, maybe there were like 12 different sunglasses, and then it's basically like combinatorics. You basically say I have 12 of these, and then I have 10 of these, and then I have 5 of these, and then you kind of multiply all those together and see how many unique images can we generate from this. If it's over 10,000, which is quite easy to do, then you'll probably have enough, right? Awesome. So, what's the problem here? What's the problem? Come on, we're gonna start throwing these things out. What's the problem, Chad? You're gonna get a lot of these.
Problem?
What's the problem?
Problem is,
I'll give you a hint. Maybe there is no problem. Maybe that's okay.
I don't think there is a problem.
Okay, but there are some consequences to this, right? Okay, what's the consequence here? Well, typically 10K projects need to sell out to reveal each purchaser's PFP. Traditionally that's what would happen. The reveal would happen after the mint out. We call it the mint out. That's when all of the 10,000 items were sold. This places pressure on the project to hype the sale and mint out the project. And the faster all the NFTs are sold, the sooner the reveal. So what happens if the project doesn't mint out, which is now happening for a lot of projects? And what happens if the reveal is instant? So 2 consequences. What happens if we don't mint out this project? And if we do have a reveal, what happens if we just make the reveal instant? As soon as we mint the NFT, we immediately see an image. So if the project doesn't mint out quickly, the sale can drag on indefinitely, right? We just don't know, okay, we didn't mint out, how long should we keep the sale going for? We're in unknown territory here. We want it to sell out in a minute, right? If the sale continues indefinitely, then none of the PFPs can be revealed if you're doing a reveal. None of the PFPs are revealed. No one knows what they minted, right? So if we are doing a reveal after the end of the project, everybody's just sitting there with these basically placeholder images until the reveal happens. So the consequence of that is if we don't know what we minted, we can't flip our ultra rare NFTs for Pavilion and Ethers, right? Or so the story goes. Yeah.
I mean, in the case where a sale just stalls, why not just cut the supply?
So that's what this project did. I bought a Babylon Misfits, and this was what I got for like 3 months. It was a reveal image, right? This is a placeholder for, no one knows what they're gonna get until we do the reveal. Well, this didn't mint out, and we just kind of got stuck. I was thinking like, should I get more organic stuff? I don't know, it's like, I might get some more organic stuff so that Nate can get some snacks. Or a bottle of water, throw you a bottle of water. I literally was at Costco for like 20 minutes reading ingredients, like, what should I get? All right, so I participated in this project. Here at the beginning, when the contract got deployed, this was the Pinata endpoint. So this is what the metadata would point to. So if you click token URI, it would give you back that. Well, sometime later, they decided, like whoever was running the campaign decided to actually do the reveal. So it didn't mint out, but they ran this transaction where they call set base URI. This is 165 days ago when I took it, but the project was like 6 months ago, so they didn't actually run it 165 days ago. They ran it basically like 3 months after the start of the project. And then after they ran that, this is the endpoint that gets called back when you ask for the base URI. All right, so it went from this, and that was basically static image. And then when they changed the URI endpoint, it points to this. So what happens? Well, they revealed it. So this was my NFT that I got. I got 834. So if we go back, you can see so this is like DYVRN. And if we go forward, we can see that at the end there, DYVRN, and then my NFT. So it went from the left image, which was kind of like the placeholder, to that's what I got, right? But I didn't know that until they changed the URI endpoint to point to where all the data was. What I got was, well, what does this thing look like? Did I win or did I lose? I don't know. I just minted something, and then for like a month or 2 or 3, I just kept checking it. It was the same image. All right, so that's one consequence of this thing. So why not reveal that immediately? Why not just mint it and then I see what I got? Okay, immediate reveals lead to this kind of gaining the mint campaign. If we all know which tokens are available and can predict the next tokens that are to be minted, then we can strategically snipe more desirable PFPs. And so this happened with the Bufficorns with the ETH Denver. So ETH Denver did a series of a 10K project, and it was sequentially incrementing. So token 1, 2, 3, 4. And then kind of a criticism that came out of that was, well, they all had different traits, and you could kind of figure out when the next one would come up, so you could strategically like buy or wait out the minting process. So that's a consequence of this. If we all know which tokens are available, we can predict the next tokens that are to be minted, and we can like kind of snipe these things, right? So what can we do about this? Well, we can use VRFs and fair mints to kind of protect ourselves against the sniping game. So why fair mints? So if the PFPs are immediately revealed and the minting increases monotonically, then everyone can predict which tokens with their rarity traits are next available to be minted. All right, so what's monotonically increasing mean? Somebody who isn't, well, I think, no, you're not needing. Yeah, Nate, go ahead. I know you're not going to need it, but you need it.
I'm going to guess it's incrementing sequentially across.
Yep, that's it, right? So it just means we're going up in increasing order. We can't go down. It's always increasing, and it's sequentially going up. Right? 1, 2, 3, 4, 5. So we know what the next mint is going to be based off of what the last mint was. Yeah.
But that doesn't apply to the most rare thing at the end or at the beginning, does it?
No, but you know, if it's immediately revealed, I'll know what rarity traits are coming up next. Because, for instance, on mine, 834, if we're on 832, I know that there's two mints that need to happen for me to get 834. And what if 834 has a really, really rare trait? typically more rare traits mean they kind of in the aftermarket would be worth more. They're more desirable, right? So if I know that like 834 was coming up, maybe I'll buy the next 10 just to get 834, and it's worth it for me because I know that I have like the rarest one coming up. If we know what's coming up, then and we know what the traits are because they're all listed already, then you can kind of gain which ones you might want to buy, and then maybe you don't want to buy for a little while because there's a bunch of crap in front
It's
of you.
like counting cards.
It's like counting cards. So the advantage with fair minting, however, so you have the immediate reveals, right? So you can kind of look at this as an advantage or disadvantage. So this can create animosity in the community. So where strategic minting can gain ownership over more rare, desirable tokens, ultimately it neuters the concept of randomly generating unique tokens with varying rarity traits. So that's where we started. We're randomly generating 10,000 tokens, and some of them are more rare than others. Generating PFPs with random traits captures that idea, the ideal of fair minting by having a random chance of obtaining a token viewed with rare traits. So this is all about random chance. We're randomly generating these things, and if I randomly buy a certain token at a certain time, I might get a token with more rare traits than others. So here we're equating random with fair, right? However, we destroy this concept whenever anyone knows the order of the tokens with more rare traits. The ever-present problem of public data. Everybody gets the same view of the data, it's all public. But we can get back to this fairness with VRFs, right? So what are VRFs? I'm going to read you this, and then if anybody's confused about that, we will talk about it. In cryptography, a verifiable random function is a public key pseudo-random function that provides proofs that its outputs were calculated correctly. The owner of the secret key can compute the function value as well as an associated proof for any input value. Everyone else, using the proof and the associated public key or verification key, can check that this value was indeed calculated correctly, yet this information cannot be used to find the secret key. A verifiable random function can be viewed as a public key analog of a key cryptographic hash, and as a cryptographic commitment to an exponentially large number of seemingly random bits. That's where we get the pseudo-random part about this. The concept of a verifiable random function is closely related to that of a verifiable unpredictable function, whose outputs are hard to predict but do not necessarily seem random. Okay, that was a lot of words. Verifiable random function. Kind of random. Pseudo-random. So verifiable just means we can verify it, we can do something to kind of measure what the output is based off of what the input was. Random means it gives enough kind of entropy or enough bits of information where to us it kind of seems random. And a function meaning, you can call on it to give you back. You can put input in and you can get output back, get out chat.
Why can't I just programmatically use it like a random function?
Because I can programmatically look at your function and then determine what's the next random number that's going to be coming out of it, right? So this is the problem with randomness on the blockchain. Everybody says, well, we don't know what the timestamp of the next block is going to be, so we'll use that. Okay, fine, but how the blockchain works is all that information is public, so all the miners who are trying to put together the next block are putting in timestamps and trying to hash all of the transaction pool together and come up with a block that works for the difficulty. Well, if we're all watching the transaction pool and we're all looking at that, it's possible for us to kind of guess or estimate what that timestamp would be, or as soon as it's minted or added to the blockchain or mined, as soon as it's mined, if I'm looking at that, I can tell whether or not, say if it's a game, based off of what that timestamp is, if I'm going to win or not. So we can kind of play these games where we all are looking at the same information. So kind of what we need is random information that we can't predict what it will be based off of anything that came before it. So we're kind of in this game where we can't really get randomness within the enclosure of on-chain data. We can get randomness from outside, not inside. Kind of a game point, right?
Is that like, sorry to interject,
Yeah.
is that like the petty, like, oh, well, this was generated from an an ASIC, and we know how this ASIC could be reverse engineered potentially if someone had the secret data and like leaked a trade secret or something of that ASIC. Is this seems like a different category of like actually not random data.
Yeah,
Or is it
so
in
that's
the-
kind of like everybody tries to decrypt encryption, right?
Yeah.
And there are tactics that you can use if you listen to how the disk spins or how that particular ASIC is going to work, to try and figure out what the information was before it got encrypted. This is kind of saying, I don't know, I want to create a way where I don't know what information is coming up next. It's tangential, like it's a tangential problem, but this, trying to get randomness on-chain and use it in on-chain applications is basically trying to achieve a state where you're getting information into the space where all the information is already known. So you're trying to get unknown information into a very well-defined space. I don't know if that answered your question, but
Well,
we want information we don't know. We have
Yeah.
no idea how we can predict what it will be.
yeah, I thought that. Cool. Okay.
We can talk later if I didn't quite get it. All right, so getting fair with randomness, or almost randomness. We can achieve a fair mint or get back to the concept of randomly minting tokens with more rare traits by, well, randomly minting tokens. So by randomly assigning token IDs to successive mints, no one knows the next token ID to be minted, which makes sniping a rare NFT impossible. This is good, but here there may be dragons. So, minting random NFTs, what's the big deal? Well, it's useful for fair mints, but there's a problem. What's the problem? Apple bag. What is the problem with minting random token IDs? You're not going to eat any of these, so I'm going to go with the back. Yeah, go for it.
I don't know the answer, but I just want one of those.
Yeah,
things.
right? That's a good point. Just give me something and I'll give you two.
Okay, all right. The problem is that because you can still count down the number of IDs that are left, and so.
Okay, that's good. It's pretty close. So we're randomly minting tokens. So we don't know what's coming next, but we have to mint somehow like 1 through 10,000. So what could be the consequence of not knowing what the next number will be? It's a little bit of a stretch.
I mean, what if all the rare ones just come like in the first one?
That's a good, yeah. Well, that we're willing to accept. We're willing to accept that because it's random, right? I'm gonna give all three. Can you pass this? All three back. Okay. So, Kevin, I think.
Since you gave I have something to add.
Yeah.
It's more on the image side of the PFPs. Unless the actual project or the team, the artist, accounts, if they accounted for how the different attributes will look on top of each other. So let's say you have like a picture of a bird with a crown,
Right.
and you have 10 different images of the bird. How does the crown actually look on top of those images?
So that's really interesting because if you're doing dynamic NFTs, that is a consequence. And that's kind of where we're going to now. We're doing more dynamic NFT stuff. This stuff is all static. All the 10,000 images are already generated before any of this starts. But that is a consequence if you are doing dynamic NFTs where you're saying, we have all of these parts and at the time of mint, we're gonna stick them together for you. So, very good idea, but all of these, just for this particular talk and what we're talking about before, most of these projects are all static. It would be like, this image is already done when you buy it. Did you wanna jump in, Kevin? Did you have something?
No.
Okay. All right.
Keep it in.
Chase,
I know you want to do a cross room.
I do, I want to throw it.
Throw.
I was like, I'm
Might
just
have
like,
to frisbee it.
I'm using, yeah, in my mind, it's all the MIT open courseware lectures. They always throw frisbees at everybody.
Just don't tell me you're gonna throw it, just throw it.
Just throw it, okay. Oh my gosh. What's the problem? Well, okay, so there's an issue of keeping track of what has been minted. If we don't know what token ID will be minted next, and we are getting random numbers which will be transformed into the next token ID, then we might come across duplicate token IDs to be minted during a campaign. Yeah, right? Why is that a thing? All right, so this has to do with basically the set of data that we're going to be using. But yeah, go ahead.
I was gonna say, well, I mean, isn't there like a duplicate checking or something, you know, like before
Well, we have to do that because we don't know. So the next number is unknown.
Okay.
If it's unknown, I don't know if I'm ever going to be. I have not seen it or not. I just don't know what it's going to be.
You know the set of knowns, so I can check.
Yeah.
Why can't that? It's
Back
one
check
check
it.
thousand.
Right? We're getting there. We're getting close. We're getting close. Okay, let's take a look at an example. Okay, here's where we're getting into some code, and then there's some visuals, so we won't fall asleep. And if anybody's falling asleep, I have a whole bag of these. All right. So this is pulled from our contract. We use this function signature called create NFT because it's not the mint. It doesn't actually happen here. So create NFT happens. The next line there is request ID equals coordinator dot request random words. Okay, this is a bunch of boilerplate that comes from Chainlink. Chainlink has this coordinator smart contract, and in that contract is this request random words function. We override that, or we overload that. We stick in this very specific magic formula. Okay, that has to be very correct for it to work. But we stick in that magic formula, and basically what we get back is we get back this request ID. So it's just a number. It's basically like a reservation number. What we'll need is to remember who requested that. We're going to save that. Okay, and that's kind of all we need to know. We basically make a request. We say, hey, I have some randomness, and Chainlink will handle that for us. All right, so what happens next? Well, we get a call back, right? We made a reservation, and then we get a call back with the randomness. So the coordinator contract will call this once the randomness is ready. It will give us the request ID that was issued when we made the request. And then here's the random words is basically an array of all the information we asked for. Right? It's basically going to be an array of random numbers. So in here we get from the random request, we save the user who was asking for it. So we get that back, and that's going to be our NFT owner. And then this is a function that's going to basically transform the random words that we requested into a random ID. This goes back to what you said. It's like, well, don't we have to count? Don't we have a range of stuff? We do have a range, right? It's 1 through 10,000. So we don't know what that number is going to be, but we're going to basically transform that number between 1 and 10,000, right? And that's how we're going to keep track of things and also take this unknown number that we're going to get and kind of make it useful for us, right? And then the mint happens here. So the mint happens in the callback from the coordinator contract, and this is where the actual number, the token number, is associated with the user, right? So this is where the mint happens. The mint doesn't happen when you request it. The mint happens on the return trip. So here's the problem. What happens if we get a repeat right here? What happens if whatever this information is translates to a random ID? It doesn't have to be the same information. It just has to transform back to the same ID. I asked for blah, 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 I got 10. I asked for blah, 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 I get 11. Great. I asked for blah, 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 I get 10 again. Different information, I somehow got 10 again. Well, we can't have two owners with the same ID. That defeats the whole purpose. Everybody wants their own owned NFT. All right, so here's an example. More pictures. I asked for some junk, random, like I want randomness, and I transform that, or I use a function to basically derive a token ID from that, right? And I get token 5, right? So this will be our little array. It's got 5 elements in it, and we're 0 indexed. That's going to come back a couple of times, but we're 0 indexed. So the index of the first element is 0, we go to 4. It's going to be a little awkward, but basically we stick in token 5 there, right? Next time we call it again, random stuff, translate that into an ID, we get 1, then we get 4, then we get 3. What do we need next in this sequence? Ah, perfect. All right, we need 3, right? How do we know that? Well, we're keeping track of what happened. So in this one, total's 10. What's the next one that's going to come up? What do we need next here? 5, right? I'm looking at 1, 2, 3, 4. I don't have a 5. So the next one's 5, right? How do we know? Well, actually, it could be 5 or 10. But the way in which we figure out what's going to be next is, well, we're keeping track of what came before it, right? So in order to avoid 2 users receiving the same token ID during the minting campaign, we would need to know which token IDs have already been assigned to the owners, and if we ever see a token ID that has been previously assigned, we would try to find another token ID that is available to mint, right? So we keep track of all the minted tokens that were assigned, and we also have a pool of basically what's still available, right? Yay, problem solved. Yeah, these. All right, except the problem isn't solved. Why isn't the problem solved? Maybe.
Is this really gas inefficient?
All right, next hurdle. we keep track of all this off chain. We don't have an issue. We would just track every token ID that would be minted and maintain a pool or a queue of available tokens, right? Upon the next mint requested, we would interrogate the available token queue for the next available ID. This is super easy to do off chain. Problem is, we are doing this off chain. We're executing these instructions on chain and asking the DVM to do this computation. So the computation isn't hard, but it is costly on chain. And it's not very gas efficient. So the problem is, how do we keep track of what was previously minted so we can maintain a pool of available token IDs that can be assigned to new mint requests in a random fashion? How do we do that in a random way? Well, the challenge is we do not want to repeatedly iterate over an array of tracked token IDs. Why?
Gas. Nate
It's expensive.
said it.
It's expensive. It's too costly to do on chain, and it suffers a quadratic time complexity, right? If I have 10 tokens, and for every one that gets minted, I need to check. Let's say we don't check 10 times, but I need to check however many were minted. Well, if there are 10 tokens, and every time I need to check, I need to check 10 elements. Well, that's 10 times 10 is 100, so that's an n squared time complexity. We call that quadratic. We call that bad. Basically, computer science says that's that. Don't do that. We can do better. We must do better. What do we do?
Is it possible to just use a data structure?
Kind of. That's kind of what we're going to do. We're going to use a data structure to do this in a way in which we can keep track of what came before and also offer up a next random token ID that hasn't come before. So how do we do that? Jump ahead here. What we're going to do, let's make a deal. We're going to keep an array of length of the available token IDs. All right, so we have 10K project. We're going to get an array of 10,000 elements. And then when we mint a new token, we're going to check this array at the index element of the token ID. I'll show, there are pictures for this. We're going to take the value at that index and then assign that as the next token to be minted. We're going to take the value at the tail position and assign that to the index that was just minted. We're going to decrease the size of the array because now we have one less token ID. We're looking and we're swapping. So here's the setup here. We're going to have, again, we're zero indexed here. A little awkward, but we're going to have these token IDs in the array, right? We have 1 to 10,000, all right? So our queue size at the bottom is 10,000. So the size that our range basically is 10,000. So here's kind of what the algorithm does. We're going to start here. We're going to get that random information. We're going to translate that into a token ID. So for here, it came up as token ID 3. So we're going to look in our third spot. So we're zero indexed here, so we kind of actually just go 1, 2, 3, which ends up being something like look in the index of token ID minus 1. We look here, and sure enough, there's 3, so we'll take it. Yay, we minted 3. Great. What do? Well, we take the element that's in the very last position, that's 10,000, and we stick it in 3. So now we have 1, 2, 10,000, 4. Right? And then we chop off this the array, and so we went from a queue size of 10,000 to a queue size of 9999. And we're going to do that over and over again. So let's do it again. Here's a duplicate. We asked for some random junk, and we got token ID 3 again. So we go look at ID minus 1. We look in here. We have 1, 2, and it's 10,000. No problem. We'll take 10,000, and we'll assign that. And then we're going to go to the end. It's 9999, and we stick it in this position right here, 9999. And then we reduce our array size by 1. Went from 9999 to 9998. And in this way, we're able to receive random data from a Chainlink VRF coordinator, translate that random input into a token ID, look up the value of the next token ID in our queue, and then mint that token ID. We do not need to iterate over our array to make sure that this random token ID is available to be minted. We simply look at the value at the index element. Then we assume that the value in the tail position of then we assign the value in the tail position of the array to the index we just assigned. And we reduce the array by 1. That's it. We keep track of assigned tokens and available ones at the same time. So this tracking procedure allows us to keep track of randomly minted tokens so that, did I already say that? This process, no, I didn't. Because the really fun part about this is we went from quadratic time to constant time. We skipped linear time, which is rare that we can ever do that. So can anyone tell me why this is constant time complexity? Jeez. Need a frizz. Why is this constant time? I'll ask. So,
Is it because you're not looping, you're checking numbers in a straight line instead of iterating over a bunch? I don't need to. I'll give my snack to Chase.
No, I'm over snacked, please.
Alright, so instead of going through each one of these sequentially and trying to find where we should be, we don't do that. We say, give me an ID, it's 3. I just go look up into 3 and I take whatever's there. That's the same operation over and over again. Regardless if there's 10,000, 100,000, doesn't matter. I'm just going to whatever you give me, I'm going into that array. Now chat, why is this constant time and not linear time to look up and index in an array?
Because you know where it's at because you have the previous location.
How do you know where index 3 is in an array?
Because that's what you've minted up to. And you're keeping
Right.
track of that in the
But
contract.
how do I, so to find what the element is here, I'm just teasing because it's a small group, but to find what the element is in here, why is that constant time? Why can't I just jump to that and not go at the start of the array and say, what's, let me count 1, 2, 3 sequentially.
So if you have an array, you're typically keeping track of that array based on the last minted NFT. So if I just minted n, then I know that the next index is n plus 1. So I can just go straight to n plus 1.
Right. That's, yeah, I'm confusing the question here. Basically when the compiler lays out an array in storage, it knows how big each
Oh, write that down.
unit, it knows how big each type is of the array. So these are uint256s. It knows that each array element is a 256-bit number. So it doesn't need to start where the array starts and then look sequentially. It basically just does the math really quickly to say, you want index 3? Great, it's 3 times the beginning address point that this array starts times 256 bits or whatever. So we're actually just, we're doing a quick math computation to jump to array spots. We don't have to iterate anything, which gets us away from all that time complexity issues that we were at earlier. So we can do this stuff cheaply on chain. Right, so now how do we get the randomness into the contract? Well, we use Chainlink VRS. So Chainlink VRS has services on Ethereum, Binance, Polygon, Avalanche, and Phantom. So if you're working on any of those networks, you can use Chainlink VRF. And basically Chainlink VRF is going to set up a structure so that you can get randomness back from it. How does it work? Well, I set up the first line here. Basically, you kind of have to register with a subscription manager to get a subscription ID. You just basically kind of make a reservation in the coordinator and put some link in there. You say, I want to make a subscription for randomness. And then the live demo session is kind of where we do this. Someone will ask the consuming contract for a transaction. The contract will basically talk to the coordinator. That's request randomness, and that will emit an event. It goes to the Chainlink network, and then sometime later it sends a message back to the VRF coordinator with the randomness, and that comes back to the consuming contract. So our little NFT contract says, give me randomness. It goes, get you randomness, comes back, and it calls back that fulfill randomness function when the randomness is ready to come back.
So in this case, the VRF coordinator is paying for the gas to contact the contract or to respond.
It kind of forwards gas on your behalf, because when you set up the subscription manager, you have to deposit link to it, and then all of the gas is denominated in link. So it kind of does this equation and says, well, you owe me 0.005 for Polygon link to process this. And then it says, great, I'm going to go check on your subscription. Do you have that? You do. I'm going to go ahead and do this call for you, and then I'm going to debit your account. Right? So it's basically a deposit that you put down to do all that. All right, so what does this all mean? I'm going to jump over this, but you basically use Chainlink smart contract to say, give me some randomness, and it'll say, are you paid up? Yes, it does a couple checks, and then it says, okay, great, yeah, here's some randomness back for you, right? So let's take a look at how you do that. So back to our create NFT here. This little magic incantation here needs to be correct, but if you stick this stuff in and this request randomness function already exists, this is basically boilerplate, you can use this to get randomness into your contract. Yes?
Sorry, quick random question about Chainlink. I know like very high level about it, but like does that Chainlink network, does that where does that take place? Where does that live? Like,
So that specific network is their VRF network, and so it's going to be different from their Oracle network, and it's going to be different from their Keeper network. So they have 3 solutions out, right? So that one is basically a bunch of computers that are running Chainlink code to operate in that network. So it's basically a computer program running in servers in the cloud, ostensibly, and they're all running the same code that Chainlink puts out, and I believe they need to be providers. So I could be wrong about this, but I'm pretty sure it's a kind of like a bespoke network where they only allow certain providers to participate. But basically, it's a bunch of computers that are running Chainlink code to say, all right, we're running this program, and then we're going to look at your VRF coordinator that you tell us what it is, and then anytime we see events come off of that VRF coordinator, our machines will, it's probably like a round robin. It basically says, okay, either it will average a bunch of those, like say there's 10 computers doing all this, and they're all like spread out all over the planet. They're all running the same code, but they'll all either get requests in a round robin fashion, or they'll all pool requests together and then kind of like average you a number or something like that. So I think with this particular model is you have, let's say 5, and then a request comes through and it'll go off to number 1, and then a request will come through and it'll go off to number 2, and then a request will come through and then like number 3. So they all talk to each other, and it's just basically computers that are all running the same code, right? And so this is off-chain, and this is the specific proprietary network that Chainlink is providing for the service. All right, so the deets are this. You need this key hash. It's basically it's an identifier that maps to a job, essentially. You don't really need to know a lot about it, but it's a very specific number. It's in the documentation. It's nothing you would need to know. It's just basically like, I need this specific code for this specific network, and you would look that up and you would provide it. Subscription ID is basically what you're going to get back from the subscription manager. Request confirmations are going to be how many blocks that do you want there to be before the randomness comes back. More blocks, better randomness. Less blocks, not so good randomness. Callback gas limit is basically how much operation are you going to pay for. If you request something that goes beyond your operational cost, it will fail. And then number of words is how many random words do you want, or how many random numbers do you want. So this is kind of what the steps to would look like for the subscription manager. You go to this link here for Polygon and you create a subscription. There's one on the bottom there, $291. But once you create a subscription, say $284, that's not ours, you would get an administrator address. So that would be able to do functions like admin, basically functionality on this. So you can you don't need anything to deposit, but basically if you wanted to remove that subscription ID and take off the link, you'd have to be the admin. Yeah, question?
I just a quick question about the previous slide with the callback gas limit. Like, suppose there's a gas war happening during your mint, and your gas limit isn't set high enough. What happens to the NFT project? Does it stall?
So it won't get, the request won't go through, but it stays in their queue, their job queue, and they will reprocess it. And then after 24 hours, I believe, if that's correct from what we talked with them about, after 24 hours, you can basically call them and say, can you jumpstart that? Because it kind of fell off, but it should go through now. So I think it would probably get delayed, and they would try again to re-execute the job. But it's a good question. If there is a gas war going on, and you're, like when I was running the demo, it's like 100,000 gas limit. For whatever reason, you said, I'll never go over 500,000 on this project because I'm only getting one word, and for some reason your gas went 5x in a particular block, you'll fail because you ran out of gas. So in those cases, we usually put a bunch of gas in and hope for the best, which is kind of crazy.
It
but
is
it's
a
all
potential attack vector, right?
tons of attack vectors here, right? Tons of attack vectors. So you're never going to get away from censoring transactions. Somebody can always get into it because everybody can come and play. You kind of always will get, and we've seen that before. We've actually seen that in the real, in the wild. But if you do get a subscription, basically you'll get an ID. That's the ID. That's the subscription ID. Here's who made it. How many consumers. So the consumers are basically the contracts that will interact with it, and how many fulfillments. So how many times did it give back or how many requests for randomness, and then how many times did it fulfill. And then here's the balance section. You have to put some link on it in order for any of this to work. Right? Okay, so when we fulfill randomness, just keep in mind here, this is all boilerplate, but this is an overloaded function from the coordinator contract. So you have to do this if your contracts will actually work, because it's an abstract function in the coordinator, so you have to overload it and implement it. This is just a check that we do. It basically says if you're already at 0, you shouldn't do anything that follows, but this is all what we've seen before. Get back your owner and then generate an ID, right? And then the SafeNet actually happens in here. All right, so Chainlink makes it pretty easy to do the randomness. There's a bunch of boilerplate. You have to get the arguments. They're very specific arguments. You have to get them correct. But once they're correct, and if your contract's okay, you can get randomness. So they make it kind of a pretty much turnkey operation to get randomness. Let me see here. I'll just kind of go through this real fast. Yeah. So magic incantation. I had a professor once who said that, you need a magic incantation for this to work. You basically have to get this key hash, subscription ID, request confirmation, callback gas limit, num words. Those are the things. If you can get those, you can figure out what those are, and you can get those correct for the network and your project, you'll get randomness into your contract. Just a couple of things. You need a valid subscription. So you need that subscription ID. You can't just incorporate this and then call it. For one, you'll never get past the subscription ID part. You might just put in something random, but that has to be associated with your account. So you need to sign up with their service to do that. It is, though, a decentralized process now, so you don't have to go through any kind of like vetting process to get a subscription ID, but you do need to have a subscription ID with the contract, the smart contract coordinator. And then there's a couple little caveats to this. You can run out of link. The deposited link, there it is. So what happens here is it estimates all of the work that you're asking it to do at once. So I've had this happen, but it is possible to say, I want 5 of these things to happen where I didn't give enough gas, and it'll check the balance and say, can I process 5 of these at once? And if it can't, it will fail. And that could be due to you just don't have enough link balance on the subscription. We'll get to the end. So there's a couple other caveats, but basically that's pretty much it. Are there any questions? One question. That was long. That was way long. But we can talk. And then if anyone is interested in live coding, I can just walk you through what that means. But basically, it's looking at that VRF contract, implementing that, and then doing some some random minting. Yeah. Okay, clap over. Great. Hint, VRF stands for verifiable random function. Does anyone know how we verify that information? I'll leave that for after the recording. Perfect. And then we had a question.
Yeah.
Sorry, what was your name?
Hunter.
Hunter. Right. Toby. Yeah.
Toby, thank you for the presentation.
Yeah,
It's awesome.
absolutely. Yeah.
Learned a lot of really interesting stuff. My question is anyone else doing this besides Chainlink, like getting randomness into these NFT projects?
So Chainlink is doing Oracle services. There's other Oracle providers out there, and randomness is a big issue. So everybody wants randomness. We've wanted randomness for a while. With that in mind, with the merge, you get the beacon chain, which gives randomness. So you could use the beacon chain for randomness in the future. I think that solution will come online a little bit. But Chainlink provides randomness. I'm not sure of another Oracle service off the top of my head that provides randomness. However, an Oracle service is just getting off-chain data on-chain. So in the past, what I've done is used an Oracle service to go scrape random.org for randomness and bring it on-chain. Yeah. So they just kind of codified this and said, here's a bunch of boilerplate, put in these right, parameters, and we'll run this whole service for you.
So does that mean like as the beacon chain randomness gets more whatever robust, then we don't need Chainlink anymore?
That means if you want to figure out how to get randomness from the beacon chain, you can. That means if you want to get randomness from Chainlink, you can. It's going to offer you a different thing. I mean, if you're already used, like for instance, once we deploy, I think our contract is actually deployed. So once we deploy this, we're not going to get randomness for beacon chain. It's going to be from Chainlink, right? Even though, in the future we could, the contract's deployed, we're not going to touch it. It's kind of set in stone. But yeah, you can. But you can also just get randomness from Chainlink using their Oracle service. This is just something I think that they're doing for lotteries, principally, for anybody who's putting in lotteries to do like random selection. And then I don't know anybody doing fair mints with the randomness, but the VRF is a programmatic way to kind of simulate provable randomness. So that's what they invested in. In computer science, there are verifiable random functions that are generated. And I think there was another project I was reading about, but off the top of my head, I don't know of another project that is as far along with randomness as Chainlink. However, with the beacon chain, so the reason why the beacon chain needs to spit out randomness is because you have to select a validator, and you cannot know who that validator is before they're selected, or otherwise, as we've seen with Solana, you could actually do a denial of service on the next validator, and then you don't have a validator for your next block. So that's a attack vector for proof of stake. But so the beacon chain needs to give out good randomness, because you have to select. Basically, we're doing the same thing. We have 10,000 validators. Which ones comes up next? 10. Great. How did you get that? Oh, we got randomness from the beacon chain. What's the next one? 34. We can't predict what's coming out next.
But that's like, sorry, it's another topic and another conversation, but like you mentioned earlier, it's all on chain, so we can't have randomness. What the beacon chain gives you randomness, but it's a chain. So how does that
Yeah, I don't know how the beacon chain is generating the randomness. They could do it how Chainlink implements this VRF, which is they back look at the previous blocks and they use all that information to create a random number. And the reason why that works is because you might be able to like guess the timestamp of one block, but it's really hard to guess the timestamp of 10 blocks or 100 blocks. And the more blocks you go back, the harder it is to predict when you crunch all that down what that number is going to be. And that's why there's a thing in here, or one of those parameters was request confirmations. So the number of blocks confirmations the Oracle node will wait to respond, the minimum and the maximum confirmations you have. It doesn't really say, but basically the more blocks you wait, the better that randomness is going to be, because you can't really identify, like it would be really hard to predict crunching 10 blocks with all the information in it, what all that information would be to get the next number out of that. The beacon chain could do that. I don't know how it's implemented though. I mean, they could be doing a couple things where they're looking off chain as well, but the way that Chainlink implemented their VRF is by back looking at information and saying like, okay, well we can all look at the last 10 blocks, but it's really hard to predict if you crunch all the information in those 10 blocks what the number's going to be, because I can guess one block, and I can guess kind of like the current block. If you reorder these transactions, I know what the transaction pool is, like I know what the limited information is to make the next block, but to do that 10 times in a row is hard. Good question about the beacon chain. I mean, ideally it would be like we'd have to look up like how exactly they're generating the randomness. I don't know if you know. I'm not sure about the implementation of that. But that was the whole big thing of the beacon chain. It's like beacon chain needs to generate decent randomness because we can't predict who the next validator is going to be.
So, will the problem still exist for the need of randomness in this scenario if the numbers of the token ID are sequential from 0 to 1k or 10k? So if we introduce, right? So like if we introduce a number that isn't like 0, 1, so on, so which is how other chains are doing it for other stuff, right?
The problem with when I started this, started this, I was kind of saying, this is for what we've seen before, this 10K PFP NFT project. In that, the way that that project is set up, and Chad knows this, I mean, because he was doing these dynamic NFTs at the hackathon, but when you set those projects up, you have sequential data. You know that you start with token 1 and you go to however many you want. If you have gaps in there, I mean, that's a way to get around this issue, but all that information is known ahead of time. So if you have gaps, I know you have gaps. Like as soon as you put up the endpoint, I don't know if anybody knows, when you look at all of the information, it's just a bunch of metadata files. If you want, I can pull up what ours look like, but it's basically a folder and it's got 10,000 files in it. So if I wanted, all that information is public, unless I withheld the reveal. If I said I'm not going to show you where the data is, then we're back at the start point where you don't know what the mints are. But if you do know what the mints are, and I can see holes in the token IDs, then I know, okay, well, it skips 2 every time, so I know that the next one's going to be 12 when I'm front.
Correct. So do we care about making NFT, the first NFT minted to be 0, and instead of just give it a big string number?
So there are ways to, so this is an interesting way to do things. You can actually hash all the traits as your token ID. So you don't know what your token ID is going to be. You can hash that. It's not a 10K PFP project, but you could do that. And that's a way to do dynamic minting NFTs is like, well, I don't know what traits you're going to get, but I'm going to hash them all together and that's going to be your number.
Yeah, because it's been done so because when it's a public permission, like the case here, right? So it's like, okay, it's publicly permission, so like it's public, but I'm trying to have some permission. I will try, it makes sense to, but like other permission network have done it. Where instead of assigning a small number that predictable, like from 0 to 1K, you really assign something like, which is really cool. I know Chad knows about it, which is DID, like decentralized identifiers. And what's funny about that is that obviously they're huge. So, and you don't care because like, you never care about how big the wallet ID is, right? You just care about like the last 4. So it becomes the same thing, right? So you have a huge number for each, and then what you can do with that as well is the off-chain calculation. Meaning, once this is out, it's like I don't care. This is huge numbers. It literally is post quantum calculation to break it, right? So now they're already out, and I'm just gonna come and say, okay, let's randomize that and use computer science stuff. And then you can do that like off-chain.
Did you say use computer science stuff?
I mean,
yes. Anytime we can, we should. Right?
yeah, I mean, like what you just said earlier.
I found a library that does computer science stuff. Makes it work for us.
Yeah, exactly.
So there's a couple issues there. I mean, it's all yes. The answer is yeah, absolutely good. If it's permissioned, you can do whatever you want. You're like, I got token 10. Woo! Oh no, it's 34. Oh, okay. I guess it's 34. The issue with Ethereum is it's on chain. Whatever you do, even if it's a mapping, even if I got token 10 and it maps to a hash, I can see it. I know what token 10 is going to map.
If the rarity or the perk, utility exclusiveness, whatever it is linked to the output, not the original. So I'll give you an example, right? And this is based on like a true actual a use case, right? So imagine this. Imagine if I get the first 10 NFTs, right? Get exclusive access to a perk that let's just say go to maybe as a package to go to Hawaii, right? Mm-hmm. And then the first 10 gets it for $1,000 instead of $1,500. So now I do want to get the first. So there will be fight over that, right? So now and this is a lot of money there, right? Imagine this is a huge package. It's actually a company I worked with on a project called, you can look at it, it's called Resort Pass. So that's exactly what I do.
Okay.
And then I worked with them for a while, for like a year and a half, to tokenize their services, and that's exactly. We use all the public, and what we end up doing is like it has to be permission blockchain. Because on public, they want to be on public, and that's what we end up doing. So we take the number and say, okay, so this is 0, you don't care about that. This is gonna coordinate to a DID that lives off chain. So scanning, processing off chain, and then you go say this is rare because of this, not because of that.
That's fine. That's permission. That's off chain. You can do whatever you want.
Well, no, you can do it permissionless too.
You cannot.
Right?
No.
How come?
Because I can see all that information. Anything you do on chain, if I can see it, whatever game you want to play, it's like, great. What are you doing? Oh, I see what you're doing on the table. You get to see everything.
Okay, but you're missing something, right? So the rarity, right? So let's go all the way to the foundation. So So you're saying because this
I
is
see what you're saying. If I don't know what that rarity is when I mint it, I don't know if it's rare or not.
exactly because like it's
That's-
saying like it's only saying this is rare because it has a glasses and has some because and that itself is not random enough to produce a good output of randomness.
So in that regard, I could say I have 100, like in your case, I have 10 NFTs. 1, 2, 3, 4, 5, 10. Everybody buys them. It's like a raffle. Everybody gets one. But you don't know what you get. You just know that you got 5.
Sure.
And it's like, okay, great. And then after that, I can make one of them rare. Sure, it's just all that process gets off chain. It depends on how far away you want to get from. Do we have a smart contract with rules that we can all see what's going on? Because I can just, can I cheat? I could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 9, 10 was the best one. I decided it and we got the best thing. Sorry, it was all fair. but we don't
Especially
get to
if
see
the
it.
person who's deciding, who is the chain who trying to keep that decision
Exactly.
on the chain.
Sorry, that's
is
a
the
bad
actual
example.
gas.
But yes, if I'm the one who's assigning the IDs and I'm the one who's assigning the trades, you can. But I think there's a way in which you can do like semi-permissionless, or you can do some games where you can use off-chain stuff to where you can still make it fair. But for Ethereum, the like kind of the hardcore principle is everybody gets to see and audit everything that's going on, so I can tell if I want to play, right? And if I can't tell what the rules are a little bit, I mean, we do this a lot with like all different things. I could make a lot of money by just trying like doing this stuff, right? I don't know exactly what's going on, but there's a lot of risk, but there's a lot of reward. But the kind of foundation is everybody gets to see, and the rules are the same for everybody.
Sure.
But there's definitely a way to use, it doesn't necessarily even have to be permissions. Like you said, you can kind of like figure out a way to do it permission or public, but you're basically kind of like, we're all leaning. It goes back to the randomness thing. It's like, well, you're getting something from off-chain, you're putting it on-chain. That violates the whole principle of we're all supposed to know what we're doing on-chain. But it's so useful that we'll allow it. Like how do we show, how do we verify that what we asked for happened in a way in which didn't get compromised or stuff like that?
Yeah, I
So-
mean, that all depends on the utility, right? So as long as
Absolutely.
it's called source of truth, right? So as long as the source of truth is not compromised, then really what comes after, which is the utility, should be fine. So as long as I can go back, say this smart contract, this token, and then if there's any transfer of events, then there's a listener who will ping that, right? But beyond that, like I should be able to do every single thing off chain because it's free. That's the magic word, right? And then without breaking the decentralization or actually violating the the transparency, right?
Right.
Saying, well, it's mine, I can show you
Right.
it's my token.
So we kind of get into the zero knowledge stuff at that point, where you say, I got some stuff off chain. I don't want to show you what it is, but I can show you how it was calculated, and you can run a proof that will convince you that what I'm talking about is what I can prove to you that the information that I have is the information you're looking for.
So I think ultimately, kind of what you're coming at or you're getting at is how like where does the trust lie, right? How many layers are you willing to accept trust? Ultimately, like the best case is you just trust the math, right? Like in the case of ZKPs or in the case of verifiable randomness, but then you also trust Toby as a developer to not have a function on a smart contract that says, hey, I can change the base URI where the metadata lives, right?
Right.
And then at some
Totally,
point I
that's
charge-
a great point
Right.
too. Like,
yeah.
if I can change it, I can change it again, right?
Right.
Change
It's like where does the trust lie, right?
Right.
Like
Yeah.
the gold standard is math, right? But then you keep going up from there.
And yeah. Oh, sorry, go ahead.
Yeah, no, that's,
I was
I
just
think that's where
Nate
he's
was
saying
talking about incentives before we started, and it comes down to that. Like, how much incentive do I have not to change that URI after we, like, if the project does really well,
Yeah.
and there is a big incentive for that to stay the way it is, and it creates value by being the same,
Yeah.
then maybe it will be this. I mean, we can't say for sure.
This-
There's no certainty.
That's interesting you bring that up because sorry, I meant to.
Yeah.
Because I was thinking about like you could use somebody's data that doesn't care about the mint to generate randomness. So like Vitalik's next transaction, what's going to be the amount that he sends of what token and generate randomness from that? Because he's not going to like go to someone and be like, yo, I'm going to get you the rarest NFT for this. He's probably not going to do that. It's not worth his time. It's not worth credibility if someone finds out about it. So it's secured by incentives rather than math.
I mean, it's a good point. Sorry, what was you mean?
Hideout.
Kind of Hydar's point is like, how else can we use different mechanisms to create, basically you want to create a situation where you don't know exactly what's going to happen. And it's really hard because all the information is public. So how do you publicly share all this information and just say, this is how this machine works. This is exactly, I will show you exactly what comes in. You can prove what will come out. In that scenario, how do you take something like that and say, but we don't know what's going to happen if you put in this stuff? You can't. So we have to like come up with these other kind of creative ways to do that. So this is one. IDAR seems to have a couple other ways. I think to Chad's point, like blending, where do we trust, what the incentives are here, what other mechanisms exist. And then I think we kind of both said that with the incentive mechanism where you said it was 1,000 for the first thing and like 1,500 for the second. Kind of, I think the winning strategy, and I was talking with Nate earlier with Bitcoin, I think is the magic there, is this incentive structure kind of made it work. It's like, we probably will benefit more if we play by the rules than if we violate them.
Yeah, exactly. It's basically a carrot and stick, right?
Yeah.
And it's really you should always promote the carrot because it's better.
Right.
Because like
More people win with the carrot.
exactly. I mean, like in general, be the good thing you can think of, right? So.
Oh yeah, go ahead. Sorry, Hunter, did you have something?
Yeah, so like I think you already just kind of answered the question. Like, there's all kinds of ways you can do this randomness, so we just like choose what we want to do. But like one question comes out of an example, like like a lot of these NFT projects, they want to introduce more utility, and they want their NFTs to evolve over time, like mutant apes and all that kind of stuff. So like that, then you get some more centralization because you have to have these ways of introducing randomness on top of NFTs that already exist, and yada yada. So like, is any of this actually going to be able to be fully decentralized as we add more utility into NFTs in the future, or are we always going to be stuck with these sort of centralized types of solutions to get these utility and randomness into like our NFT collections as they evolve?
That's the question. The answer is philosophical. But it's an open-ended question. Like, there's no answer to that, but where your supposition is correct, is the more you try to do stuff, the more you're going to pivot towards centralization because you can lean on that. Everybody wants this decentralized, or there's always this push for decentralization because of the consequence of centralization. But a lot of times we forget what the benefits of centralization are. We know what the downfall is. I mean, we get censored, or someone can tell us what to do, and we don't have a choice. But when we get away from that, I don't know what projects you're associated with or what you've tried, but for us, the further we decentralize, the crappier our product is. It doesn't work as well. And everybody is used to a Web 2 experience where they're like, I push a button and something happens immediately. It's a fight, and I think it's probably going to be project to project, like, Mutant Apes, like, they're probably going to go full centralization to try and make something really cool, and then maybe backpedal, or, do some figure out, once they got something that's compelling, how much can they get away from that while it's still usable. But, I remember the Mist browser in like 2015, trying to do transactions with that. It was horrible. It was like, this is the worst thing ever. I have to have a whole chain that's synced in order for me to make transactions. They're synced and all this stuff. It broke all the time. But that was decentralized. That was decentralized, and it sucked. But it was really cool. I mean, at the beginning it was really cool. So it's an open-ended. I mean, you would have just as good of an answer as I would. I can say from when we develop, the more I use AWS, the better the product feels. And the more I use decentralized infrastructure, the worse it is to deal with, to maintain, and by maintenance I mean, sure, it's deployed, it works, great, whatever, but I'm not in charge of that maintenance. Who is? I don't know. Like, what's going to happen what happens if gas goes by back? I don't know. So, yeah, it's a good question. It's one that we'll probably be asking for a while. I don't know if there is a right answer, but we're at 8:30, so
Yeah.
want to...
Just real quick, let's give Toby another round of applause.
Thank you. Thanks for coming.
Yeah. you guys mind taking a quick survey? We do these now for the meetup, just so Toby can get feedback on how he did, we can get feedback on how we did, and we can continue providing these meetups. I'll just share this link really quick.
Hey, Chad is up there, let's be on our phone.
Huh? What was that?
Like, Chad is up there, let's ignore him, be on our phone.
Yeah, no, you guys can totally ignore me, but this helps the organization. We appreciate that.
Yeah, thanks for filling out.
Yeah, that was really awesome, Toby, thank you so much.
Yeah, thanks for the question. That's a good, and the feedback too. I think a lot of people are just continuing to ask questions and trying to figure out what they're comfortable answering. And I don't think there's any right answers here yet.
Yeah, and I definitely think, for especially like for technical people, I think they missed out on the good information because this is like, sometimes you watch a YouTube for that, right? Like you fall asleep or you don't think is important enough but yeah, excellent for me.
Yeah, this was really cool. It was like, it felt like it was like walking through your process and solving this problem was that basically it.
Yeah.
That was really cool. Yeah, that was awesome to see.
And so there is a repo where I implemented this. I don't think we'll have time to do it tonight, but if anybody wants to try it out,
Is it that the one you said on Zoom, right?
yeah. And if you have any questions about it, feel free to contact Chad, and Chad can get a hold of me, or you know, I'm in the Discord in ETH, so if you want to try and find me there, I'll answer any questions. But that one's kind of like hard hat. If you have Node installed, you basically can install the repo and then run the hard hat commands, and that will deploy mint contracts, and then tell you what your mints are. And you can see the mints will be random. And then it's completely implemented there. So if you want to actually look at how it was implemented or what that code means, or you can see the boilerplate and how that stuff works and how to implement that stuff. It's all in there. And if you have any questions, just reach out to Chad or me if you can find me, and I'd be happy to go over it, just so you can get a little bit more context if you're interested. And if not, then by all means, don't look at it.
One comment from the live stream.
Oh man, there's the live stream.
This guy is high, man. That kind of passion is never natural. That was amazing. And then someone else said, "Is it a chocolate bar?" So maybe we could show what those things were.
I don't know if
You guys
anybody-
missed out.
Man. Oh, I'm glad people were live streaming.
Yeah. And then we had V Dizzle who said she couldn't make it, but hope everyone is having a good time. Thank you, Valerie.
Thanks for watching the live stream.
Last thing I'll say, guys, is if you guys are here next week, we're doing an awesome event with Disco. Evan, their CEO, is going to be speaking about the DIDs. Adar kind of covered what DIDs are. This will be a great introduction. And they're currently in beta, but ETHSD is going to be the second community to get access to their private beta. So everyone will be able to create a data backpack, learn about their API, and start building on their service, which is really cool. It's going to be exciting. It's going to be dancing, maybe not dancing. Hopefully Toby's there. But yeah, if you guys can make that, that'd be awesome. That'll be next week, October at Launch Factory.
Cool. All right, thanks everybody. Thanks
Thank you, Toby.
for people watching on live stream. That was
Thanks,
awesome.
Pete's home as well.
Yeah, I was hoping there wouldn't be any leftovers, but you know what? More for us. Well, thanks everybody for getting here. That's really great. And then if you do have any further questions or